Hey guys, welcome to day 2. So as you can see, I've changed the before I planned to just have everything in one readme and just get day 2, day 1, day 1, day 2, day 3 all the way down, and then maybe a table of contents so you can get through. But I think that's still pretty hard. It'll be long session of scrolling. So I decided to split it into different files. I think that's a much better idea. So now I have day 1, I can change to day 2. Feels a lot better, right? So yeah, quite a lot. Day 2, much more complicated as well. I start off by revising what I did near the end of yesterday, which was kernel space, user space, system calls. Just a slight refresher for myself. Once again, added the analogy. And but yeah, the new things I learned was hardware. So things like USBs, you're connecting USBs, hard disks, whatnot. How does Linux detect that, right, and work with it? So a thing called U-event, right? That's what Linux does. The Linux kernel detects the state change and they generate this U-event, which is then forwarded to the user space. So there's, like I said from before, kernel space, user space, right? And then there's some commands to help you out. Demessage, the base message from the kernel string buffer, revealing how hardware was detected and configured. And there's UDEV ADM, utility management tool for UDEV, and UDEV ADM monitor, which shows you in real time when something gets disconnected, like your mouse. And you can get information from hardware through these commands, which is list PCI, things such as video cards and Ethernet cards and whatnot. Pretty much anything that's attached to the motherboard. List block, there's some gives information on block devices, key terms, and then there's the major and minor number, which are these ones right here, right? And the major run represent different things like RAM, hard disk, parallel printers, and the list CPU. Let's run that. So as you can see that my one's a 64-bit. It's an Apple device, and these things here, thread, core, sockets. I also added here that 32-bit versus 64-bit, how much memory they have, and the fact that you cannot run a 64-bit OS on a 32-bit CPU, but you can do it the other way around, although it's not recommended. And then sockets times cores, so sockets times cores times thread. So 1 times 2 times 1 is 2 equals the CPUs, which is the total number of logical processors. And then we got list memory. We can list the available memory system. Also, you can use the free command, which I've used here. So I can just run again. Just running G's. So memory 3 gigabytes. Used up 1 gigabyte. 0.3 apparently. And another important note is the sudo command. So an example of this is if I try to extract detailed information on the entire hardware configuration of the machine. Let's try that. So lshw. Warning, you may be incomplete or inaccurate. Output may be incomplete or inaccurate. That's super user. And I think if I can find where I type that code around here. Nope, maybe a bit higher. Oh yeah, here. Warning, you should run this program as a super user, right? So what that means is pretend I'm just at the very lowest, hierarchy, and I don't have permission to run crazy commands. Some things are locked behind. You have to level up to get there, but the sudo command really useful. Pretty much it just says screw all that, let me run it, give me the highest position there is. Kind of like in Windows when you run an application as administrator. This is the same thing, very simple, just write sudo and then continue on with what you're going to do. So let's try it again. We'll ask for your password, right? Because I guess it's sensitive information. And you can't see me type it, which is really nice. And I can't see you, so it's okay, I got it right. And then it'll give you the information, yeah. So very useful sudo command. And next we move on to Linux boot. So how to initiate it? Two ways: start a Linux device in a halted or stopped state, or you can reboot your Linux or reset a running system. So there's 4 steps to the Linux boot process. The BIOS post is the first stage, and POST stands for power on self-test. And the BIOS runs this test to ensure the hardware components which are attached to the device are all working correctly. And if not, then it just stops and an error message is displayed, like you can't continue on with this process. But if it does, it moves on to the next stage, bootloader, which loads, like the name, that loads and executes the boot code from the designated boot device. So typically for Linux, this is like the first sector of the hard disk. And the most commonly used ones is called grub2. They mentioned that, and yeah, they mentioned that a lot. Well, not a lot, but they just chose to mention that. I guess it's very popular. And after the user selects the boot option, between whatever options that came up, it will load the Linux kernel into memory, and then it passes all the required parameters to the kernel, and then just leave it to the kernel to continue on to the kernel initialization. Because when the Linux kernel is loaded, it's in a compressed state because it saves storage, so it'll need to be decompressed and then loaded into memory afterwards. And then the kernel begins execution, performs these very important tasks such as hardware initialization, which detects and initializes all the hardware devices, and then memory management, which sets up a virtual memory and allocates memory for the system. And once everything is operational, it looks for the initial process, which is essential for the environment, for setting up the environment before the user space is initialized. Last step, the init process or service initialization, which runs off, I think, system D, I believe. This is the most modern Linux. Oh yeah, this is the user system D. Yeah, why is system D so popular? Because of parallelization, which starts services in parallel, like can start everything together, which significantly reduces the boot time. And to check what init system is being used, you can run list option L and then sbin init. And next we got run levels. So as you can see, my Ubuntu has a GUI. It's got a graphical interface, so we can run systemctl get default to check what number that is, but I believe it is free. So get default graphical target. Oh, well, it doesn't tell me number, but yes, that is free. And you can see run level 3 boots into command line. Yep. Oh, sorry, I believe, okay, it is 5, sorry. Yep, that's 5, not 3. 3 is just a terminal once you boot up, just a black terminal. And you can always just change it by doing systemctl set default multi-user.target to change it to the other one. I'm in graphics right now, so I'll stay here for now. And then we move on to file types. They gave us a quote. everything is a file in Linux, and there are 3 types. Regular files such as images, pictures, scripts, data files. There are directories, which I've mostly experienced, right? Alice. These are all directories. And special files, which there's quite a few of them, such as character files, which are devices under the dev file system. And we got block files, which are block devices under the dev system as well. Links. There's 2 types of links. Hard links, which connect 2 files. They share the same block of data, and when you delete one, the other will also be deleted. Deleting the link will delete all the data. And then there's symbolic links. It just acts as a pointer, so if you delete it, doesn't really matter. Won't affect the file. We've got sucker files, which enable communication between 2 processes, and named pipes, which connects one process as an input to another, and there's only one direction from that. The first process goes to the second, and not the other way around. And how do we identify file types? Using file, the command, or you can use ls with the option ld. So you can go like that, and let's just pick Africa. So you see how it starts, the first letter is a D. That means it's a directory. Yep, D for directory. Next, we move on to the hierarchy. So some key directories and purposes. We have home. We're used to this, right? That's where I'm coloring at. Yep, home. And op, this is mainly for third-party programs. When we install them, they always typically go here. Next, we got mnt and temp. Mount and temp, I believe, used for temporary mounting file systems. Temp is reserved for storing temporary data. We got media for all external media such as USB drives. We got dev, which contains special block and character device files representing hardware such as external hard disks and your mouse or your keyboard. We got bin and etc., which contain essential programs like copy, move, make directory. Those all reside in the bin directory. Etc. is vital because it stores the majority of the Linux config files. We've got lib and lib64, which stores the shared libraries required by programs during runtime. And we've got user, which is the modern Linux system. And then we got user, which the modern system uses to store user land applications in the data. And contains things like Firefox, Thunderbird Mail, stuff like that. And then we got var, logs. This is like when something goes wrong, you find the logs from here to see what happened. So it contains logs and cache data. And then lastly, the df command, or disk file system command, very useful for viewing any details about each mounting file system. Quite a lot of this foreign to me. Even though I can write this down as notes, I can't really read it as well. These are still just this hurts my brain to look at. But I'm sure eventually it'll be like English to me, right? Also, I did some more learning, LinkedIn Learn, so I left the quiz so that I can do it with you guys. Not with you guys, but I can do it here so I can show that I'm actually learning stuff. And this had quite similar stuff to what I learned today, but a few extra commands here and there, a few extra things, such as what is the valid way to start a bash script file, right? I didn't get told that in Code Cloud, but luckily I had other materials to learn from. Right, what would you typically append items in your path variable? That one for sure. what's wrong with this? We know that I learned it last time, right? It should probably not be spaces between A and the quotation. On a stopwatch, that's just real, I believe. How would you export a variable to access it in a child process? Yep. Where should you look to obtain the most detailed guidance? That's man pages info. Probably just the web, right? Yep. What's output? So A equals 543. So echo A. So it'll be 543 at the start. Into a gap, right? Into the time and into A. So 503 start, this one. Yep, I believe, because it has a gap and it has the the commas are still here. Which code starts a new process? This one. And just like that. So yeah, that's day 2. Hope you guys managed to learn something. To be honest, this is, if I were to I'll probably forget this within a few weeks or even a few days if I don't come back every now and then. I think I just need to find a way to maybe find a project to work on, something that I can use this for other than just learning about it, trying it out in my Ubuntu server, right? So yeah, I think next steps I'll probably start looking into certificates, harder certificates, or such as Linux Plus. I know that's pretty far away, definitely, but give us a goal, maybe a project. I can find a project. Who knows? But yeah, that was day 2. Thanks for tuning in. See you guys tomorrow.